Lissa Productions.
Welcome back to Experimental Physics and our series of experiments involving radioactivity. This experiment is aimed at showing that the dependence of the intensity of gamma radiation on the thickness of shielding material is an exponential function. So we expect the relationship n equals n naught times e to the minus mu x, where mu is the probability of scattering per unit thickness. So we take the natural log of the corrected number of counts and plot that versus thickness, and the slope is the scattering probability. So you'll need to measure an independent count of background radiation before you begin, and it's also a good idea to do that at the end of the experiment to be sure that background hasn't changed significantly. Then measure the total number of counts as a function of thickness of shielding material, correct all the data for the presence of background, and plot the natural log of the corrected count versus the thickness of shielding material. What we'll do is carefully put the Geiger tube back into its support stand and place a radioactive source after you've counted background. Put the radioactive source right in the bottom of the support chamber. Then what we want to do, since this exponential function applies only to gamma rays and not to beta particles, we need to filter out the beta radiation. And a nice way to do that is using a piece of plexiglass. So there's a shelf on which you can place the plexiglass beta filter. Just put that up on the top of the instrument, right underneath the window of the Geiger tube. And then we'll measure a number of counts with no shielding other than the beta filter. Then we'll just take a piece of shielding material, such as these blocks of aluminum, and place a block of aluminum right on top of the source and measure the number of counts in a convenient time interval. And then place another block of absorbing material right on top of that and continue to measure the number of counts as a function of thickness of material up to a total thickness of about 2 inches. So once again, you'll just plot the natural log of the corrected count as a function of thickness of shielding material. The slope of that line is minus the scattering probability, and the objective is to show that different materials, the electron density of the material affects the scattering probability. So we'll compare 2 different materials and see which has the largest scattering probability. So once you've finished measuring the scattering probability for aluminum, then you can repeat the same set of measurements for lead absorbers using the same procedure. So again, measure the count from the source directly without any absorbing material other than the beta filter. Remember to keep the beta filter in place when doing all of the gamma measurements, and place a piece of lead right on top of the source, measure the count in a certain time interval, and repeat that for the whole stack of lead up to 2 inches. And determine the scattering probability of lead, compare that to the probability of scattering for aluminum. So, as always, I'd like to remind you to keep your exposure to radiation as low as reasonably achievable. And the 3 common sense ways of doing that are to maintain proper distance. Don't be any closer to the source than you absolutely need to be in order to do the work. Work efficiently to minimize the time of exposure. So do your work, plan what you're doing ahead of time, do it quickly and efficiently, and return the source to your instructor as soon as you are finished. And finally, if you need to be near the source for a prolonged period of time, make sure that there is some sort of shielding between your body and the source of radiation so that the shielding material absorbs the radiation rather than you. So keep your exposure to radiation as low as reasonably achievable when doing all of these experiments.